Hello, everybody, and welcome to, what is this, the third plenary meeting already? If you know me, probably know me as the co-chair of the drone cluster within ESIP, where we've been wrestling with the complexities of the drone data pipeline for a couple of years now. This session actually sprang out of inspiration coming out of the drone cluster, in the sense that because drones are a new platform, one of the things we've been exploring is as drone use matures, it's efficient to reuse the work of others, perhaps more so than in more mature domains that have had decades or longer to mature their processes and tool stacks. Here, if a PhD student has spent a year qualifying a sensor or developing a process, it's efficient if that same process can be used elsewhere. And so this session was sprung out of the idea of discussing how we facilitate and ease and increase greater reuse across neuroscience in general. The obvious motivation for that being the complex environmental and social challenges we're facing. I don't think anybody in this audience is ignorant of that. Perhaps one of the best examples of success in this that I know of is CERN. I'm an engineer and I've been privileged to work on some of the engineering tasks in building that. And what astounds me more than even the physics that the CERN project produces is that in order to carry out that work, international collaboration, interdisciplinary collaboration is essential. A nation could choose to spend the money to build a Hadron Collider themselves, but no one nation has the expertise to develop it. And given the societal environmental challenges we are facing in the coming years, you could argue that we all the more need to see that kind of level of collaboration happen in the earth sciences as well. That's a complex question. There's low-hanging fruit of just reuse infrastructure. ESIP is obviously an expert as a community on data sharing and software sharing. But then there are the more complex layers to this challenge. And that's why I've used the word translation, pausing on reinventing the wheel and facilitating translation of complex algorithms, translation of approaches to complex systems. All the more we need to see greater levels of that translation. And that's much harder. It requires grace and humility just on a human level, but it also requires translating for each other, jargon and language. It requires in-depth engagement, and it's difficult, but necessary, I would argue, at least for now. So I'm very excited to have this panel with us to discuss this complex space. I hope nobody in the audience writes it off as, oh, we've heard interdisciplinary again and again. And I know all of our funders are prodding us in that direction, but that's for good reason. And it's more than just words in a proposal. We need to actually be doing it, but that's far easier said than done. So as this idea sprang out of drone thinking, two of our panelists I know primarily out of the drone world. Peter Webley is the Associate Director of Research at UCASI, which is Alaska drone department at the University of Alaska Fairbanks. So we've known each other through various drone collaboration, and given he works in the drone space, I know he's an expert at wrestling with interdisciplinary work. Steve Cornett is the Deputy Director for E-Research at Monash University. Again, if you're familiar with ESIP, you will know that we've engaged with the Australian environmental community quite a lot, and so it's great to have him in this room. Again, we know each other via drone work, where he's an expert, again, in environmental sensing, drone use. Next, I'd like to introduce Chris Jack, who's the Deputy Director of Climate System Analysis Group at the University of Cape Town. He is a climate modeler, but also has dipped a little bit into the drone world. Finally, Anthony Arden is a research scientist at the Polar Science Center at the University of Washington. and he has got extensive experience in the space of collaboration, particularly in the use of hackathons, in facilitating exchange, or translation, for want of a better word. So yeah, don't be quiet. We are going to make you engage in this session, but I'll hand over to Charlie now.
Thanks, Jane. So Jane and I'm a facilitator, designer, interaction designer and facilitator, and she and I have been chatting about how to make this a little bit more interactive than a standard panel discussion that we're used to doing. And so this is the only reason I'm telling you the name of this activity is because I know I'm going to continue to call our guests fish, and I want you to know why I'm calling them fish. This is called a fishbowl activity, and essentially what we want is, instead of our guests talking, giving a talk or a presentation and talking to you, we want them to talk to each other, and it be more of an informal chat amongst peers. And so what that might imagine that they have, they're here at the ESIP meeting, they've gone into the hallway and they bumped into each other, and they're discovering that they have a lot in common, and they begin to talk about that. So with that, what this is going to look like is we're going to allow the fish to talk to each other. We have 2 prompts that if you look at the agenda page on the Kickoff chat window, you will see the kickoff questions that the guest fish will discuss. They'll have about 12 minutes to chat about what successes they've had and applying the research outputs of another domain to their own, or vice versa. And then after they chat amongst themselves about that, then I will give them a warning, and then they'll have like 8 more minutes to chat amongst themselves about what's preventing them from reusing these outputs from others more often. And the way that this is going to be, and then after they chat for about 20 minutes, we'll put people in breakout groups where you'll get to discuss what you've heard, and then formulate questions for them to continue the discussion. And I'll give you more directions on that when we get to it. But for now, to make this a little bit more feeling a little bit more intimate, what I would like everyone to do is to take your mouse and hover down at the bottom of your Zoom window, and turn off your video unless you are a fish. Unless you're going to be part of the fish discussion, please turn off your video. So that's first. And then the second thing I want you to do, I want you to hover over someone else's, one of the other blocks that's not your own, and go and look where it says 3 dots. So if you hover over someone else's name, and you'll see it says ask to unmute, and then beside that it's 3 dots. Click on the 3 dots, and then go down and click on hide non-video participants. And so everyone has to do that for themselves. We can't do that for you. And what that will do is anyone that does not have their camera on, it will turn, we won't be able to see you. And that way we will only see the fish talking to each other. So if you could go ahead and do that. And if you can't find it, please click that in the, say so in the chat, and then we'll give you more directions. So go ahead and turn off everyone else, hide non-video participants for everyone else, and let me know when. Okay, it sounds like everyone's done that. Now I'm going to hide my video, and okay, fish, you're going to talk. Do you have you found the questions in the document?
Yes.
Yes. Okay. I'm going to step out and let you have it then.
All right.
Okay, so hey Anthony.
Hey.
So and hi others. So I think part of it we might want to do is, given everybody's listening in over our shoulders, is also that to introduce ourselves to those listening in. Jane's given a little bit of it, but we might want to sort of give a little bit of where we've come from, and a little bit of briefly about our backgrounds before we sort of jump into the first discussion point, because that might sort of give an inkling of where we're coming from based on the different approaches, the different methods that we've worked upon. So for me, as Jane pointed out, I'm an unmanned vehicle researcher, but that's not sort of where I've come from in terms of my geoscience background. I started off with the use of spaceborne data for natural hazards. So this was volcanic ash. Hey, Steve. This was volcanic ash and volcanic lava flows. And then I progressed to how to automatically track volcanic ash clouds using atmospheric modeling. So there was always a need then to compare observations to models to see how well the modeling was performing. Then I moved over into the use of webcams for natural hazards, and then on to unmanned vehicles. Again, the need for comparison of automatic detection processes, algorithms, to manual analyses and the data streams kept getting faster, more frequent, more spectral channels, more available data sets, spatial resolution, and as a result, some of the applications developed that I worked on I was doing with spaceborne data became apparent as useful tools for ground-based systems and then airborne systems. So that's where I'm coming from. So I guess, other fishers, do you want to chime in from the other side of the bowl?
Yeah, I can go. Chris Jack here from University of Cape Town. I guess this is not a very familiar community to me. I do have some experience with drones, and that I've crashed a few drones, and yeah, we have a sort of very fledgling drone activity within the research group. But I think, yeah, I mean, my background is computer science and computer modeling, high performance computing. So that's kind of where I've come from. And yeah, got very involved in climate modeling, regional climate modeling, downscaling. And I guess my main sort of experience in this area is there's a lot of demand for climate model and climate science output to integrate into other disciplines in impact modeling, hydrology modeling, crop modeling, and then also integration into policy making, decision making. So yeah, a lot of my work these days is trying to kind of move data, information, knowledge across disciplines and encountering a lot of the challenges there. Yeah, so I'll talk more later about what those are, but that's kind of my background.
I'm happy to go next. I think different to Jack, I don't own a drone and haven't owned a drone, so I'm sort of most appropriate for these things, I think. My background is I'm a computer scientist. I operate what you guys would see as a HPC and cloud and eScience lab, and that's my pay job. I have a bit of background in geoscience in that I did a stint at Caltech and have been involved with the national infrastructure that's for geoscience called AuScope in Australia for some time. I typically do more geophysics and geodynamics and have quite a substantive sort of HPC background from that point of view. However, over the last couple of decades, I've also been heavily involved in other domains such as image characterization and health and medical sciences and things along those lines. And my counterparts and I across the nation, which is a collection of these national facilities looking at ecology, looking at plant phenomics, industry applications in mines and things like that, have gone together to create a cloud ecosystem to basically make campaigns consistent, how we describe campaigns consistent, to look at how we store data from drones to ensure that they're increasingly fair, to try and make it so that the barriers to interoperable workflows, data processing workflows, are made consistent. So we've gone together to create that ecosystem. It's a project that's just started, and yeah, so happy to participate today.
Great. My name is Anthony Arden. I'm a research scientist at the University of Washington. Done a lot of work in cryosphere glaciology over the years using remote sensing data, and working a lot more in the space of cloud computing and kind of building systems to help scientists share data and collaborate more effectively. So I would love to hear some stories from my co-fish about your applying research outputs from another domain into your own. I'd love to hear some of your thoughts on that.
Yeah, I guess I can respond to that, Anthony. Given I've sort of come at my current position from volcanoes, and volcanoes, there's an increasing number of webcams being placed at volcanoes, and there's more and more need for some of these qualitative data sets to become quantitative. And this could be for the use of ground-based cameras for rivers, river ice mapping, or this could be ground-based cameras for coastal erosion. And we're seeing more and more of these online cameras coming available, but they've, at the start and only until recently, they've really just been a qualitative tool. So there was an interest to develop an automated detection of new features in the field of view of the camera. So there you're starting to look at some edge detection capabilities, some image stacking for looking at non-typical signals in the data. And so I was working with a master's student on that. And then we got to, I was actually on a PhD thesis defense for the icing on unmanned vehicles. And the student was looking at the ice accretion on the unmanned vehicles, and they were doing imagery and then starting to look at video feeds of how the ice grows as the water droplets pass over the wing. And I was like, well, what about some of these edge detection, automatic detection of non-expected imagery in video feeds or webcams? How about applying those to the growing ice structure to then automatically, without having to get away from the manual tracing, which he was started off is manually tracing the edge of the ice in every image that he was capturing. And I was like, well, there's these approaches that when you're looking for natural hazard events in webcams or that you could apply to these type of images. And then I was like, well, we could start building that into airborne data. But then we would also need to do some comparisons of manual. How would a human observer trace or detect that feature versus some form of automated cloud-based algorithm, some machine learning approach where the data is being trained by what the manual observer. So from looking at lava flows on volcanoes, we even saw in the video footage at the beginning the Hawaii eruption from 2018. From looking at it from an unmanned vehicle is how can some of these computational edge detection classification tools then be used in spaceborne observations, ground-based observations, airborne observations to, as more and more data gets generated, we need to be able to look at the important information because we can't look at every piece of data set that we collect. So that's sort of my story, is that some of the techniques developed for volcano lava flows are now becoming useful for river detection from drones.
Yeah, that's really great. Christopher, Steve, do you have a story you want to share?
Yeah, I mean, I can share one that's quite different. Like I said in the introduction, I'm not really a drones person. And my work is much more in climate science. But yeah, an example of where we did something and also some of the challenges that came out of it was after, some of you may have heard of the drought in Cape Town, the day zero drought where the city of Cape Town nearly ran out of water. And post the drought, there was a big push to better understand the water supply system and the climate change. Yeah, so we were asked to provide some climate projections data to basically test the water supply system model for the city of Cape Town. And we used to, providing climate information. So we sort of rolled out our standard products, conforming to sort of climate standards and so on. And yeah, I mean, there were initially some technical hurdles of, data format interchanges and so on to make sure it could fit into their modeling system. And we pushed through that. But then what emerged, and I think what's really interesting for me in this whole space is that the obstacles were really conceptual rather than technical. So the assumptions that we were making about the data, about the characteristics of that data, even some of the sort of underlying conceptual assumptions of climate modeling were very different to what an engineer who's running a water resource model or water systems model is used to making. So in the end, the real challenge comes down to essentially finding some kind of agreement or compromise on the conceptual underpinnings of the integration of the data, rather than the technical level integration. So I think a lot of the technical level stuff can be overcome these days. There's a lot of work on standards and software tools that enable this integration. But the real work is coming to that conceptual integration of different types of data that actually makes sense in the end, rather than just produce numbers in the end. Yeah, so that's one example.
Yeah. Great. Yeah, Steve, what are you seeing in your world?
Yeah, so I thought I tried to stick to the geoscience side of things. I'd sort of go back in time a little bit. And when I first got involved, it was the late 90s. And at that point, a PhD student doing something in geophysics, in seismology or thereabouts, or in geodynamics, you would go away and write your own code, copying probably perhaps someone else's, and prove your theory and sort of file it away and potentially hand it on to your next colleague or something like that. But we sort of get a problem where not only was the mathematical complexity and the geophysical complexity getting much harder at that point, and the student was spending more time coding than doing geoscience research, the technology was changing underneath them. Like HPC was becoming parallel and all these bits and pieces, which just meant they were spending more time with the code. And so we sort of made a bit of a pact amongst a bunch of us where we were going to work on these environments that would encourage those students to spend more time doing geophysics rather than the computing. And so we started to do things like push in version control, regression tests, encapsulations, the use of libraries and things like that. And we took that quite far to the extent that we, through things like CIG and the equivalents in Australia, we had code shared across the two countries, and of these underpinning bits that linked the geophysics to the mathematical libraries and all the computer parts. And there were several great things that came out of that, like the first sort of really 3D codes to do things along these lines and so on and so forth. So that was one area we had reuse, and that's very much on the simulation side. But as time got on, more of our researchers have a geological nature, moving up the food stack, if you like, and it became more important to link real-world observables into the ideas and the things that were typically simulated in the past. And so we started to change the way that these students would express their physics and their knowledge from being things like C and things like that to being in Python. Everything else would still be the same underneath, reusing all the old codes. That's just the way they expressed it. And the reason for doing that was to enable the interplay between the simulation or the physics or the work being done and data, and to make it so that data can drive the experiment as opposed to the physical drivers. And that's kind of is what led us to where we are today with the drones activities, where the Python became described in Python notebooks, which also meant we could do version control, we could do all these bits and pieces, push them through a mature DevOps or pipeline, which meant that, you know, physics was being tested and regression tested and things along those lines, and the data processing algorithms. And we redid one of these where there was no simulation involved, but where the driver was data immediately captured from drones, all the pre-processing, and doing the work of, in one particular case, was the auto detection of faults on a plane of a volcano that had continuously, I guess, fallen away, was becoming a hazard. You know, and so from there, they were taking LiDAR data, they were processing it in a certain way. There was some parts of it which was human, you know, but we were able to narrow that down quite small. And now there are AI activities going on too, machine learning activities to try and reduce that part. And that's what's led to this sort of notion of speaking with others and saying, well, what are these sort of pipelines, and can we share that environment? And that's sort of, I think, background.
That's cool. What you guys are saying really resonates, and you know, this notion of kind of removing the barrier of a lot of this sort of low-level work so that people can get the work, the science done that they need to, and also dealing with these misconceptions across disciplines so that we can communicate more clearly. It definitely applies to the example I was going to share, which was I was in a leadership role with as the science team lead for the NASA High Mountain Asia project. So a whole bunch of scientists coming together with an explicit, actually almost requirement to collaborate across these subdisciplines to look at the water resources in High Asia. And, you know, so the precip folks feeding their products into land surface models, and then having that being shared with people looking at impact and downstream hazards, all that. And I got to see a lot of successes and challenges with, you know, how do we bring these products and data sets across these different subdisciplines, even all of them studying a pretty similar field, but still having a bit of those challenges like Christopher was mentioning around just not necessarily speaking the same language. One success I'll share was on my individual team. One of my colleagues, David Sheen, was responsible for creating these high resolution digital elevation models, these sub-meter optical imagery from commercial imagery. And he made the decision early on to just go ahead and distribute those, send them to the DAC as soon as they were available. And this was a bit of a risk on his part. He realized that. But the goal was to get that because it's such a foundational data set for all the other subdisciplines, because they needed to know the surface elevation for all these different applications. And that turned into a big success across the team because it allowed everyone to move forward really quickly. And in the end, he didn't get scooped. He was still able to do the work that he needed to do. And he published all his scripts for the processing of that on GitHub. And it was really set the stage for that really collaborative effort. So, you know, just that open data sharing, we hear a lot about the challenges and the benefits of it. That was a really clear example of where it really worked out well. Yeah, so we'll stop there and we can have a little more conversation.
Yeah, I actually would like to respond. Yeah, I was going to respond to you, Anthony, on that. It's where you're talking about you're collaborating across geoscience disciplines, but it's still a everybody's got probably a geoscience or a geophysics or background. Some of them maybe have got computational science. And I think when it was mentioned about your experiences with hackathons, is often a team of 4 engineers, if they're in a hackathon, versus an engineer, a management person, a social science background, and somebody with physical science, probably will get a more finalized product than just 4 engineers or 4 physical scientists working in a team. Because when you're producing a product for an end user or decision maker, you want to make it so they can digest the data and digest the product. So sometimes you actually need somebody from outside your discipline, or you're completely outside your own, let's say, geosciences, going to be, well, what's the right color? Am I putting the reds and the greens together? Am I putting the purples and the blues together in your imagery or your derived product? Because the ability for somebody to turn around and look at a screen, whether you're producing a real-time product, and they need to be able to straight away say, where's the hazardous area? Where's the non-hazardous area?
Yeah.
You don't want to be giving them the full rainbow of colors where they're having to stop, use the mouse, go over, look at it. You want to have a fast eyes down time so they can then go off and make their decision, inform somebody. So sometimes bringing a social science background or a graphical artist into it, you can sometimes produce a product that is more receptive by the decision maker than just a team of 4 physical scientists.
Mm-hmm. Yeah, having that diversity of backgrounds kind of ensures that it's more. Yeah, I like that.
I think there's an additional part, and I think the ability to communicate and those outside eyes are really, really important. You know, quite often we talk about, you know, and then you've got everyone here be trained the same way in the sense of, can a 14-year-old read, you know, what you've written? You know, I totally agree. The other one that I think we've come across a lot is in the example that I just gave. It's very much about building very complicated and advanced and new novel workflows. The colleagues in this drone collabs that we're performing, some of them come from a very different world, and you'll see the difference here, which is not about building the most advanced and the most novel workflows. They're more concerned about getting a country's worth of farmers to contribute image data from drones. And so then how do you take those algorithms in that same environment and have it scale up in that sort of, you know, Google-like web scale type of way and things like that. So people come, I think the different domains and disciplines bring a different way they interact with humans and what they expect in terms of scale and usability and things like that as well.
I think, I mean, I hope I don't come across too negative, but I think, you know, there's some real challenges that have come. I really appreciate the open data movement and the, you know, compliance with standards and the ability to integrate data sets. But I think what I see quite a bit with students and, you know, papers that I review is it's almost, in some senses, it's almost too easy these days. You know, it's easy to pull a precipitation data set and say, well, it's a format I can work with. You know, the units are well described. I know what this is. The metadata is good. And I can integrate it with this land surface model and that I understand. But again, coming back to sort of conceptual knowledge understanding, that integration doesn't always make sense. It makes sense at a technical level, and you can produce a product and some numbers at the end. But I think we need to hold in balance the ability to technically integrate things and the ability to conceptually and, if you like, think through what are we learning, what is the knowledge that we're producing here. So I really wrestle with how we balance this. You know, there's a lot of pressure to make data openly available, and I've developed a portal that makes a lot of our data available, but sometimes I lie awake at night thinking, gosh, this data could be so misused.
Right.
And I know it is being misused. So it's a
do you think that's something that prevents people from wanting to post their data because maybe they've had that happen to them?
Yeah, I mean, I've definitely spoken to people who said, like, I'm nervous making this available because it's a complex data set and I can see how it could be misunderstood or misused, misapplied. And I don't think we should avoid sharing data. I think we just need to think about, you know, we've put a lot of effort into thinking about metadata and how we make data fair and so on. But we almost need to go, perhaps, I don't know, maybe another level and start capturing other metadata about what is the applicability of a data set, what are the caveats and the constraints, and you know, some of that comes into fair, I guess. But
yeah, it's always a worry when if you're putting something on some online hub or attaching your data to a paper now that peer review publications can have data attached to them. Somebody's going to go and take that data and produce the incomplete inverse result, or they're going to infer something that's going to make a really bad informed decision that can have a local, national, international impact. And I think as more data is shared, then yeah, that's gonna come back, and if that person gets it out there, published, white paper, whatever it is, they're probably going to cross-reference back to your original source, and therefore there's going to be that connection between your original published result or originally published data, if it's a data set that doesn't have a publication attached to it. Then there's the worry that there's the cross connection between this possibly improperly use of the data and then your original data itself. But it is a very interesting philosophical discussion, sure.
Yeah, we talked about this a lot on our team, and especially the climate modelers, they were always having people come in and use their products and for just something that just wasn't designed for, and it was that sort of not speaking the same language sometimes, and they almost were getting to the point where they just wanted to have an agreement where somebody signed a form and said, I've read this, I understand, and like a very formal way of doing it. Another solution I saw, in my example, David just ended up being deeply embedded in all these teams where his data sets were used. He became co-author. He spent a lot of time getting connected and sharing, how best to use the data. Not everyone has the time to do that, but I wonder if that's another pathway here.
Yeah, I think that's definitely the ideal, and that's what we sort of prioritize, is that we're deeply embedded in the process. We're not just a data provider sort of plugging in a data need on the side, but it takes a lot of time, and we also have to convince the funders to fund that time, because they don't necessarily see the value of that.
We're going to take a pause right here. I invite all of the participants to turn back on their cameras at this point. What we're going to do is, in a moment, Arden is going to put everyone in trios and breakout rooms. And what we want you to do in the breakout room, so you've been listening to this on this conversation. You also have experience and think questions of your own, right? You're in a room full of people that have the same kind of interests that you do, similar, overlapping. So you're going to go into breakout rooms for 15 minutes. In the first 9 minutes, I would like you to introduce yourself to the other people in your breakout room, and then chat amongst yourself about, what are you hearing that you agree with? Maybe you disagree with some of these things. Or what is missing from this conversation that should be included, that you would like the fish to talk about next. So you'll have to distribute the time amongst the three of you. So about 9 minutes to talk about what you agree with, what you would disagree with, or what's missing from the conversation. And then we will message the room after 9 minutes, and you'll have 6 minutes then. I want your trio to agree on, because there's a lot of people in the room, and we want one question per trio. What is the one question that your trio feels like would move this conversation forward? What should the fish address? And when you decide on that question, go to the Google Doc that's under the Agenda tab in the Kickoff Chat window. And there is a place for you under the Round 1 Small Group Breakout Questions. At that time, you will type, each breakout room will type your question there so that the fish can look through the questions. And I think I've explained that. If you have any questions, speak up now before Arden puts you in a breakout room.
I'm ready to go.
Before you do, Jane and Jens, would you like to be put into a breakout room, or would you like to stay here in the fishbowl with us? You know whether you want to be put in a breakout room to discuss these things, or whether you want to stay here and talk to the fish.
Am I being put in a breakout room?
Tough choice. Stick us in the.
It is.
Stick us in the groups.
Okay,
Yes.
I'm going to put you. Okay, I'm going to open the rooms and I will see you guys later. Unassigned. Oh, we have a few unassigned.
Unfortunately, I had to take one of my office mates outside, so I missed a little bit of the instructions.
Jay, I'm putting you somewhere. Okay. We are all assigned.
Cool.
Oh, whoops.
How's it going? How did that go?
Good. It was super easy. The only thing I forgot to do was delete the room with the fish.
Actually, it worked out well because now they're chatting amongst themselves.
Awesome. Cool. Yeah, no, that was super easy. So you're a co-host, so you can bounce around if you wanted to, or hang here, either way. And I thought it was great that it worked out really nicely numbers wise that Jens and Jane wanted to go. And it was interesting how many, we had another like mass exodus when we went to put them into breakouts, and so that was the only hard part. Was I had formed the rooms when there were like 68 people and then probably 10 people dropped off. So not a huge number. But anyway, everybody got assigned. It didn't take too long.
Yeah, so maybe, do I need to give that invitation a little bit more care that, it's okay, like you have the option to just listen in?
Yeah, I'm going to move so that Ted can keep chatting in his breakout. I wonder, if we need, I think it'll be interesting tomorrow to see how they respond to the Kiko chat, like moving around in Kiko chat, instead of doing the Zoom breakouts. I think we'll lose more of them that way, but we'll probably get the right people who want to contribute. So, but I think they're also getting used to it. A lot of the sessions have used breakouts in the last couple of days. And so, I think that they're getting more kind of accustomed to being put in breakouts and to telling us where they want to go and all the things.
Yeah.
But
if you have any suggestions about my directions or what please let me know.
Cool. Yeah, no, I'm so unaccustomed to being off, and like to being able to just sit and just be a participant in the session. So it's like tonight was just really great that all I had to do was put people in breakout groups. And I think, I heard from Megan, she was really liking this format. And I think actually I should pause the live.
Color them or something.
What I can do is let's do italics or probably color. But yeah, we can color it.
I was about the color. That's bad.
There you go.
There we go. Great.
And then the privacy one as well.
Yeah, the one that's that one. I'll let one of us do it rather than both trying to do it.
There we go. We need to pick another two.
I guess one that I don't know how much discussion it might come up is the one about how to facilitate bringing together, as you said, not the 4 engineers, but the engineer plus the UXI person of I've got at least an example of that from getting involved in what are called design thinking innovation sprints, where you're bringing together the full breadth of those interested in a problem or interested in a specific need, and then getting their background, and then just putting them in teams where you've got the discipline or interdisciplinary. And that's something that's done in entrepreneurial hackathons or innovation sprints or startup weekends where people come together and the facilitators look to ensure that you don't have all just engineers on one team, but you do have a range of different people. So that's one possibly to talk about, but it's more generic and general rather than maybe specifically for the ESIP meeting.
That's great. You've already partially sort of answered that one, so that's awesome.
Yeah.
Why don't we dive into these other two and see where that takes us?
Okay, sounds good.
Yeah. You guys start talking about the drone stuff. You guys are the experts there.
Yeah. I'm just going to make some notes on the form. So to respond to that one. So yeah, hi everybody, thanks for coming back in. So the first one that we as a group picked on, which we thought was a good one and sort of comes back to the data quality trust, is the first question, which is what is the combination, it's a fairly long one, but what is the combination of data quality information and provenance to be included to enhance the reputation trust of drone data? 3 things that drone data should care about. And the group here, the trio question was calibration, accuracy and precision of location information, provenance, trying to move away from mainly using who's the person in charge as the key guide on which the data to trust. So from the drone data side, I think in terms of drone operations, the Federal Aviation Agency has set up test sites. So in terms of, and this is in the United States and internationally, there's probably other setups in different countries. But in terms of the drone operators, there's a pool of groups that the Federal Aviation Agency is working with to test and evaluate drone integration or UAS integration into the manned airspace in the United States. They also have a center of excellence that they have put together that has different groups involved. So in terms of operating and where data might come from, then if the aircraft is being flown by a group associated to one of these test sites or a group associated to their center of excellence, then maybe there's some reliability that can be placed on the safe operations of the aircraft. It was flown under the requirements to fly in the manned airspace. The data was not impacting the communications of the aircraft. It was collected in an effective and a safe manner. So that's one approach where you could look at not just the data that's coming off it, but then the provenance of like who flew it and is it being collected in an effective, efficient manner. So therefore you can rely on the source of where the data is coming from, just like you would take, let's say, a climate prediction from a specific climate center rather than somebody that doesn't have the research background or the public citations or has been funded by federal agencies. So that's one possibility of ensuring the potential trust in the data is the group that's collecting the imagery. Are they connected to some national program? Are they are they sort of approved by some some federal agency or some federal organization? I'm not sure how that might work in another country, but that's sort of some thoughts, my thoughts at least, on how we might look at it within the United States.
Yeah, I'm happy to jump in as well. And I think, Peter, stepping, I'm not an expert on the campaign scale of things and the limitations and things that are put in place by it's CASA here in Australia and things like that. And a lot of my colleagues are. But I think if you think of our conversation we had just separately while the trios were getting together, if we sort of step back, it comes back to this question of how do we build on the shoulders of others, whether it's data or algorithms or anything else. And perhaps some of the answer here comes to this, relies on the same answer, which is, if there's data released and we're scared that it could be used wrong in the wrong way or whatever else, if we look at other domains around the world, like all open source codes, people throw things along the line, over the line, over the wall, and it may not be right. And through time and feedback, they make it more robust and better. And perhaps part of the calibration and the accuracy and provenance information that needs to be provided here is, what is this data is used to prove something somewhere else, and what's that link, and then how do you encourage that link and more of those links to be built? So how do you get more tests that work off that data, and more publications or things that say, well, we know that this data works in these cases, and these calibrations and these things are proven for these cases, and you build that slate up. And perhaps some of the question is not trust of the data, but trust of if we think of it from like an open source perspective, that you are throwing it over the line, over the wall, and you know that with time you'll be making better tests by that come from user feedback and things along those lines.
Mm-hmm.
I'm not sure if I threw us off the actual question, but that's the way I see it.
Yeah, I'm not a drone expert on this side either, but I completely agree. And I think what you're essentially saying is building a community, and the trust comes in that community. I mean, that's essentially what happens in the open source world. You have a community around a particular open source product, and there's a certain trust and relationships built in that. Mm-hmm. I guess I just wonder if that is the sort of modality of how things work. I mean, maybe in a sort of operational sense, you would have repeated use of the data and you'd keep coming back to it. But I think often in research, you grab the data, you'll publish your publication, and if it's later discovered that something was wrong with that data, it's very unlikely often that it'll sort of filter back into corrections or anything.
Yeah, are you going to say something, Anthony?
I was just going to say the code sharing analogy is a good one. I mean, there are automated systems in place to check, test code that make it more likely that I'll use that particular piece of open source software over another one. And so I know there are more and more automated systems being put in place to ensure that with data as well. And that's I see that as the path forward here.
Yeah. Yeah, I think if as Chris says, if you go to an operational tool, let's say it be the National Weather Service in the United States or the UK Met Office in the UK, they have vigorous tests for validity of algorithms, and they have to have all the documentation rigorously analyzed. They have to have up-to-date documentation. They have benchmarking tests where they're comparing the algorithm against real data. And there's at least on the drone side, there's other disciplines. Climate modeling is probably the same as well, where there's even on the volcanic ash modeling side, we had some benchmark data that we tested algorithms against and saw how everybody performed against that. And maybe if we're looking at developing algorithms for automatic classification of features on an unmanned vehicle, maybe there's a benchmarking test case that could be run to say, hey, we're going to run on this data. This has been manually analyzed by an expert in this discipline. This is what they would have classified as the features of interest. Now let's do some form of group benchmarking that maybe ESIP could bring together and say, we're going to run a benchmarking analysis, and then a peer-reviewed publication could come out of it to look at, and then people could do iteration version number 2. In 18 months, someone else can come in and say, oh, I can now test my algorithm against that same benchmarking test of 18 months ago. And maybe that's something that could be an ESIP-led initiative, and especially at least on the drone cluster that Jane co-leads. And I'm sure approaches that have been developed in meteorological fields, in computer, in the HPC world as well, could be those type of processes and those workflows that have been developed could be implemented. So you're not having to develop the process of doing that benchmarking from scratch, but applying it on the unmanned aircraft systems or the unmanned systems world could be a way to transition knowledge from the climate, meteorological, and computer science community into the unmanned vehicle data analysis side. That could be an ESIP project lead.
Yeah, Peter, I think that's a fantastic idea, and I must admit I didn't make that final jump, and I think that's a really good idea. And I've been involved with some of these in slightly different areas, and I'm wondering how much of the crowd are used to where a community gets together to create these benchmarks, which then is as a pre-competitive thing as the whole community getting together to do it. I'm not sure how many of our listeners actually are used to that and have heard of that from other domains or other things. Maybe you could describe that a little bit for people.
Yeah. So from my side, this was done for evaluating the performance of volcanic ash modeling. So both Eulerian and Lagrangian modeling of volcanic ash. So how well do these models compare to observations? So we, as a group, came together, led by, I believe, by the ICAO, International Civil Aviation Organization. And there was a set eruption, so a set volcanic event with satellite data that we looked to see how geospatially our models performed to map the location of the feature and also the total material in the atmosphere. So both geospatially, but also based on the observational data. We all had the same inputs, so we all had the same starting point, and then we saw how well the models performed over time, comparing them to the observations, and evaluated at different spatial scales how they performed, and had different parameters that all the models were evaluated under. And we saw how one model compared to another under a certain metric. One may be better than the other, but under a different metric for mapping, it was the inverse. And then then on the scientific discovery side was, well, what's causing this model to diverge from the observations? How could it be version 2.0, version 3.0, and then rerun the benchmark again with the updated model? And this could be for algorithms for classification of features so this wouldn't be the aircraft itself, this would be the algorithm development for automatic classification of features, be it coastal erosion, volcanic hazards, river ice, whatever that might be. And I know Anthony probably can come at it from the climate sciences side as well, and maybe Chris and you, Steve, can look at it from the HPC side, from benchmarking test cases of computer code. But this is a pretty common practice in the meteorological modeling and the fields that I've been involved in, and Anthony probably can confirm that from the climate side as well.
Yeah. Charlie, I know we're running a bit short on time, is that right?
Yes. Is there a short answer to that?
Should we jump to one other topic just to make sure we cover a couple of these?
That will cut in to the idea generation on what we can do next.
Oh, sorry, we're actually out of time. That's totally no problem.
One thing we could do is, Jane, you could pop in here. What do you want to do? This is your session. Do you want ideas, or would you like them to continue the conversation?
It would be nice if they could address another flavor of question, perhaps the ethical, or I don't know, does it the less drone topics, perhaps?
Okay, so like 5 more minutes, maybe 4 minutes.
Sure. Yes, interesting conversation. So.
Just one other thought. I mean, I think let's go 4 more minutes, but then if the fish can hang out after this plenary is over for a little bit longer, we could also have a little more conversation too.
So the ethics of data sharing, maybe?
Yeah, well,
Yeah.
All right.
So, I mean, I really like this question. I don't know if we didn't really identify it, but the one around the cultural practices of different disciplines. to interact in an ethical manner? I mean, I think that's a really interesting question. And I think we've touched on it a few times already. I think, yeah, I think a lot of us come from a very technical kind of background, technical training, you know, where we're used to kind of interacting in very formal technical ways. You know, that's how we get our work done. And I think for me, one of my transitions from high performance computing through to climate modeling through to what I do now is learning those kind of soft skills of interacting across disciplines, interacting with people who don't think the same as I do, have different ways of thinking about their work and generating knowledge. And I think we need more training in undergraduate degrees and postgraduate degrees on how to work across disciplines, how to understand how different disciplines work and think about things. I think is really key.
Yeah, I agree with that. What kinds of things do you think would work in that space? What's kind of worked for you in exploring that?
Yeah, I mean, it kind of extends all the way down through to, you know, even some of the sort of I mean, I hate to use the word philosophical because it sounds so nebulous, but some of the philosophical underpinnings of different disciplines, some of the conceptual underpinnings, just getting a broader perspective. You know, I've been working a lot with social scientists in the last few years, and it's really mind-bending sometimes to think very differently about what knowledge is and how we generate knowledge, and having a sort of broader perspective of things is really, really important. But the main thing is getting people in a room together around a problem. And, you know, I think Steve mentioned earlier, you know, we do these things with, you know, user design experts, but, you know, I've been working with city managers and getting people in the room, talking about a common problem, trying to work through understanding each other. And then actually Jane mentioned a word earlier in the whole session, humility. And it's a strange kind of word, but being quite humble about what our discipline can contribute and what other disciplines can contribute. And I think sometimes we're quite passionate about our own discipline, and we need to kind of step back a little bit sometimes as well.
Mm-hmm. Yeah, that's great. I noticed this a lot because I spend half my time with software engineering, data science crowd, and the other half the more research science with glaciologists. And I just see that, you know, in the software engineering world, there's just an assumption that you're going to put everything into open source. And that's just the way this all works. And then I come to the other part of my work, and there's in some of my colleagues a little more hesitation, and there's a lot of good reasons for that too. And so it's just important to shift your thinking and see all those different perspectives, I think. All right.
That was a perfect 4 minutes.
Yeah, let's continue on. Oh, Charlie, I think you're muted. There we go.
Of course, as it should be. So we're going to move into one last round of breakouts. And at this point, after listening to everything that you've been listening to, it's like we want to, like, what can be done? What ideas are coming to your mind about what can be done to stop this practice of reinventing the wheel? Particularly, is there anything that ESIP or any of the other domain societies, institutions, publishers, PIs can do to boost reuse? So we're going to put you into breakouts. Again, trios for just, I think about 6 minutes this time. And we want you to start typing in the ideas that you might have about what can be done, and be specific about who else needs to be involved with your idea. And as before, please type your ideas in the Google document so that under round 2, so that we can have those after the session ends. And if you have any comments, for the host or the guest fish that you want to connect with them, or any comments or questions, you can type that below. So I think we're ready, Erin.
Okay, let's do it. And I have a few unassigned, so I will quickly zip you into a room. Perfect. I think we're good.
Great. Can you post that to the room, what I just typed into chat?
Yes, ma'am.
As a technical person coming into the science world, like, I find ESIP orders of magnitude better than many organizations at facilitating this cross conversation.
Yeah, given the discussion we had about the data quality, I put in a little item here that that says the information quality cluster and the drone cluster should talk more and collaborate.
Let's do it.
Yeah.
Yeah.
I can add to sort of a takeaway is, I'm, as I said in my background, I'm volcanoes, but there was a developed United States National Science Foundation funded called VHub, which was a collaborative online tool for sharing of data. People could sign up. It was basically community-driven online resources focused around volcanology. People could install code, people could run code, people could follow and watch the code, and it was as it was running and being processed on data. I'm wondering if of whether a sort of online hub for that integrates different levels of technology, more than a forum, but more of a online resource, could be that could connect to a GitHub data set of code, or and these may exist. I'm just thinking of, from my background, that might be useful, where there could be training built into it. That's just one thing that could come out of it, is then you could have the ability to do these benchmarking across multiple different disciplines.
Well, I think we could. It seems, Jane and all, that there's a clear direction that we should look at benchmarking in some ways, and some people need to think about, well, what's the right way of doing it in this forum, and what's the right thing to target straight away. I think the thing I would sort of say is, it'd be great to get a benchmark activity going that within a year has some useful results that people can attach to. So rather than deal and try and be holistic and sort of think we're going to solve the world, there's a lot of ideas that have been listed there, we should be able to find the one that will give us some impact really, really quickly, and then get momentum in the community. Because I think if we can get everyone to use the benchmarks and believe in them, and believe how it's making things different, then we can snowball that into more of the ecosystem from that point onwards. So I fully agree with Peter. I think what I'm just trying to suggest is maybe some thinking can go on to target it to make sure it's going to be really successful.
I think that if we can, if at least within drones and just data, the groups that are bringing in very large amounts of data, is something that I had brought up in our group, was that most of our data, the stuff that we collect as scientists, we throw out, and that's happening in a lot as we start having platforms that can collect a lot of data. If we can handle the semantics ontologies in getting the data organized so that it can be more machine compatible, we can then get the help of, or start wrapping in more machine learning and AI into our groups, so that they can actually find what are the things that are not that we might have missed in the data that we had thrown out, or that we would not have looked at before. So interacting more heavily with machine learning and AI groups that are interested in possibly just large amounts of data that they don't actually have to look at with their eyes. I killed you guys. I'm sorry.
I was putting notes into the Google Docs while I was just listening, so I'm sorry, Daniel. Yeah, I think how to ingest the exponentially growing available observations, data, whatever it might be, because as you point out, there is data that could be thrown out by one researcher could be beneficial to another, and that may not always be included as part of the resultant products from the research. So how to incorporate and analyze all of the available data that came from the original data collection.
If we needed a if we needed a use case and possibly a benchmark, I believe that the volcano eruption in the Puna district of Hawaii was Kilauea. I believe that that is still considered the most data intensive collection event in the history of humanity. So more data came out of, and because it was in a residential area that had fairly easy access, there was hundreds, if not thousands, of drones and helicopters and everything possible. USGS doubled their instrumentation out there.
Yeah, exactly.
So it would be an interesting use case of, hey, if we can, how much of this can we actually get in? How much of it can we bring up to community standards, so that so that we might be able to find discoveries that wouldn't have been seen before.
Yeah, and then how can we compare the unmanned vehicle or airborne, let's call it airborne data, because there were manned systems, to other observations as well, be it spaceborne data. There was a large plethora of spaceborne imagery for that type of natural hazard event. So the full spectrum of available observations of these critical natural hazard events. I know something like the 2010 volcanic eruption in Europe didn't just change the impact of the aviation community, it changed the atmospheric modeling community, it changed some of the ability for measurements from ground-based LiDAR of clouds. There was a big shift because of the plethora of data from all different disciplines that was obtained because of that significant event. And I'm sure the 2018 activity in Hawaii, and there's other hazard events across the world that are probably have similar plethora of data that could be used for a benchmarking analyses, and it's finding the optimal one that we think is going to give us the best return on the research.
And that'd be interesting to compare the comparisons of the two. The most significant part was the 2010 event trapped me in Ethiopia, which is a wonderful place to be trapped.
Yes,
it's going to be there in my memories forever.
Yeah. So and I think that comes back to Steve, is if we do the benchmarking, is get a focus, get a test case that we want to look at, define an approach, and be able to generate some results that benefit the wider community, in addition to those working on it as well. So it's a community-driven, community-benefited project.
I like where that's going. The other neat thing, the other possibility there is that it allows us to really quickly also expand into the social, the societal aspects of events and the benefits of our community to help the societal issues that might happen.
Yeah.
Well, one possible intersecting place to do some benchmarking would be, I would say the atmospheric science community's use of drones is relatively mature compared to other disciplines. And I would imagine the atmospheric modeling community would be very interested in participating there. So it would branch beyond drones. And the modeling obviously is such a mature field that they could provide a foundation, perhaps.
Yeah, and I think that was something that we brought up with the four of us was at the Fishes is that the benchmarking approach is well practiced in the methodology and atmospheric modeling and climate modeling community. Of if a new model comes on board, it's like, well, how well is it performing to those models used by national weather organizations? So there's going to be, well, this is the case to use, this is the observations, and you need to be able to generate these products, and you need to be able to produce this type of time series data, and we'll see how it performs to the already approved models. And there's a large plethora of, and this is done in ocean sciences and ocean modeling as well. And again, even just in HPC, as a new code comes online, it's like, well, is it more efficient but still producing the reliable results in comparison to the previous iteration? So I think looking to a community that has experience in the benchmarking, if we're focusing in on the drone side of it, would be definitely an approach to look at. But we might want to think of it as, if we look to do this, how could this be beneficial to all of ESIP's community members, in addition to those with a unmanned vehicle, unmanned systems tailoring. So it could then, because then we could even reuse the benchmarking process.
Yeah, no, definitely. Yeah, any of these new high velocity sources of data that are coming online.
Yeah, so it could be a reusable benchmarking process in addition to understanding how well these approaches and these algorithms and these perform.
So Jane, there are still 24 people on the call. So I wonder, last words, anybody, or anybody who hasn't spoken up want to make a comment to our fish?
There are some comments being written in the comment section from an orangutan, or armadillo.
So a question was 3. What is the biggest challenge? I would ask the fish what their biggest challenges are. And I guess for me, from my field, is communication capability. I live in Alaska. Alaska is a remote place. It is not downtown San Francisco, Chicago, London. We don't have 5G. We don't have internet connectivity. We have a rocket range here that doesn't even have cell phone coverage. So communication capability to be able to get the data off the aircraft as we push to beyond line of sight operations, as the data sets exponentially increase. We put 10 band sensors on the aircraft. Well, how do you get 1 band sensors off the aircraft? How do you get an RGB image off the aircraft when you're relying on radio networks or satellite phones to communicate with the aircraft? You don't have a 5G tower sitting underneath every single waypoint. That's probably the biggest challenge that I see in what I do, is just communication systems to get the critical data in the hands of the decision maker as fast as possible.
Jens, you've been pretty quiet. Thoughts? Things that stick out?
In the preparation for the session, one of the topics I brought up was what now we call the intercomparison project, the method development, that we have all these new things popping up and evolving, but from a science method perspective, a lot of validation work still needs to be done. And also across the entire landscape, I see this as a horizontal integration problem where we have different, like subtly different methods in different places, but we want to get an overall picture. So the intercomparison is, to me, an important question, both for the horizontal integration and the validation of the methods.
I think you might have a focus area for our project, Jens.
Yes.
I get to win you. This is good. Sorry, guys. I need to go. I hope that's okay for my colleagues.
Absolutely.
Yep.
Thank you so much for being on. And I think, Jane, if it's okay with you, we could wrap it up.
Yes, no, thank you very much, all our fish and everybody who participated. I think there's a lot to digest here for ESIP in general. And yeah, thank you, Charlie, for helping us run this novel session. It was my first Fishbowl.
You're welcome. I hope it was fun.
It was fun.
Very good. Thank you.
Productive.
Yeah.
Thanks.